Right, today our goal is to determine the surface area and volume of composite objects. Okay, so now we're talking about three-dimensional items. Now, you would have spent a fair amount of time on volume before. Surface area is a little bit different for some of you. Okay, the following are possible steps when we're talking about solving these surface area of composite objects. Okay, first of all, what you need to do is you have to identify the nets involved. Now, when we're talking about nets, it's like if we took the shape and we peeled open the shape so that we've peeled it open, and so that way we can identify what shapes are actually in the peeling. Okay, so the steps involved would be obviously determine the formulas of those shapes from the peel and then determine any unknowns that we might need to find. Okay, so our first example that we're going to look at for surface area is this mailbox. Now, the mailbox, when I look at it, a few different things go through my mind. I obviously it's kind of a large mailbox actually. I have a half of a cylinder. You can see it here. That's the half of a circle, and there's the other half at the other end. Okay, so I do have half of a cylinder, and the bottom part is a rectangular prism. Now, also on my diagram, I have marked a few more items. You can see from the top to the bottom of the mailbox, it's 1.5 feet. They have two ticks telling me that half of that height belongs to the cylinder and half the height belongs to the rectangular prism. Now, because if we're assuming that this is a cylinder, that means that these two sides over here would be equal. So they would be all all of those ticks would be half of what 1.5 feet is, which would be 0.75. So when I look at this, I can see, as I said, it's half a cylinder. Now, when I'm talking about peeling open half of a cylinder, I have at the one end half of a circle, and at the other end half of a circle, and then half the side of a cylinder. So I've identified what the peeling is. Now what I need to do is I have to determine the formulas. Well, obviously a circle is pi r squared, and because we have two of them, it means we have the full circle. And the side of a cylinder would be pi rh, and we need half of it. So it's a matter of substituting our numbers in, and when we do that, you can see that we have, as I told you before, the radius is half of 1.5, so 0.75. And again, over for our half of our cylinder, and our height this time, because the mailbox is on its side, as far as the cylinder goes, would be 2.5 feet. It's a matter of pulling out our calculator, actually doing our calculations. And when we do that, we end up that we have those two numbers and finally add them together. Okay, so that's half of our cylinder. Now we also talked about the bottom part of the mailbox being a rectangular prism. Now, the surface area of a rectangular prism, because I'm only concerned in actually not all six sides, because the top of the mailbox or the top of the rectangular prism is covered by the half cylinder. So when I'm looking at this, what I need to do is I have to take that into consideration. So I have two ends, two sides, and a bottom. I don't have the top. So my two ends are rectangles. Okay, and my two sides are also rectangles, and my bottom's a rectangle. So what you could do is you could actually put those formulas if you want in. The problem happens with that is all of them are going to be length times width, which is fine if you want to do that. Okay, so a matter of bringing out our calculator and actually doing our calculations, and when I add them together, I end up with 9.75. So we're almost done this question. So we found the surface area of half the cylinder and the surface area of a rectangular prism minus the top. And when we add those together, what we end up having is total surface area, the two numbers added together, and I made sure that I had units. Notice that in most of the question, I've kept 3 decimal places, in some cases 2. but my final answer I rounded to 1 decimal place. You don't want to keep rounding and rounding, so if I'm thinking to finish with 1 decimal place, I'm probably going to keep 2 or 3 until the last rounding happens. Okay, let's look at the next question. The next question talks about volume, and it's a volume of a uniform object. And what we mean by a uniformed object is something that doesn't change its shape as you add height to it. And for any uniform object, it's always the area of the base. So if I find the area of the base and I multiply it by the height of that object, I will always have the volume. So for instance, here is, what is the volume of cement needed if the depth is to be 5 inches thick? Well, a couple things are going on here. It looks like I have half a circle, and a rectangle, but they're talking about 5 inches thick. So I have to watch my units. Inches and 1 tick, remember, stands for feet. So I'm going to have to do a little bit of conversion first. And it's not too bad actually. What we can do is we can calculate that first, and that's probably what I would do. So I would take, if I want to convert everything to inches, would probably be the easiest. So there are 12 inches in a foot, and I have 12 of them, so I'm looking at 144. And now that would be inches. And if I'm looking at 30 feet, I'm looking at 12 inches in a foot, and I have 30 of them. So I am looking at 3 times 12, so we're looking at 360 inches. Okay, so now what we need to do is come up with our base times height. Well, we've already talked that my base is half of a circle plus a rectangle. And then obviously then I'm going to have to multiply that by my height. Okay, so the hardest part here is coming up with this. So half of a circle we're looking at, we know the formula of that is pi r squared plus the rectangle, which is length times width. Now, if I'm following this formula down through here, what I also need to do then, if I'm going to have times h, I have to be careful form-wise. I need to add these items together first before I multiply it by the height. And lastly, we put in our items, and you can see that again, I do not have brackets around that, which we'll remedy very, very quickly again, and multiply it by our 5 inches this time. And when we do that and we add those items together, this is what we get. And you can see then when we do that addition, with that, we end up with there are 2 items added together, 416.5. Again, we're multiplying by our 5. And finally, what happens is we actually do that calculation, and we end up with 2082.6. And it wouldn't be feet squared like I have written there. It actually would be inches squared, because that's what we did. Now, obviously, if I'm going to purchase cement, I'm not going to have it in inches. That's not what they're going to want. They'll want to know how many feet, and it would no longer be squared feet, because we're talking about volume, which would be cubed. Okay, so what happens is in that green bracket, that becomes, or in this 416.5, that's feet squared or inches squared multiplied by some more inches, and that's how we get inches cubed.